Alrighty then. Seems like I'm pushing this computer to the limit. You're listening to the Mad Science Show at www.shazizzradio.com. If you want to join in on the chat, jump over there to the superchat.html, as well as if you're on the super chat room, scroll down there and click on that peopleforpeople.ning.com link. Go over there and join those folks too. Excuse me, I've got 10,000 things going on right here. Trying to push all these buttons at the same time. Alrighty then. Woohoo! So I titled today's show, How Far Can We Push It? And there's a lot of different little circuits out there. One I'm going to show you here pretty quick is like a little micro circuit. It's like a little mini inverter. And I want to see how far I can push this little thing. It's pretty impressive as it stands. Let me see what's going on here. Okay. Let me do a little bit of maneuvering around. Baby. All right. Let's see how far I can push this little circuit. I had a friend that found this and brought this over. And it's a pretty little impressive little circuit. It's a tiny little sucker. And basically you can connect it up to 3 volts and it will put out, from what I can understand, a little over 100 volts. And so I want to see, not necessarily just today, but I want to buy a bunch of these little things. And I'm going to see how far I can actually push this circuit. I'll show you what I can achieve with it so far. Let's see if I get some doggone batteries going on. Some of these batteries got to be good. I'll just grab a couple and see what happens. All right. This is just a little, I think, 6-watt LED bulbs. Nothing to brag about. It's not super powered. It's just 120 volts at 6 watts. So that's only 6 watts. So that's nothing to brag about. But I want to see if this thing has enough juice to light this one up, and then kind of see where we can go to from there. So I've got a couple little cheapo 1.5 volt AA batteries, and I want to see what I can do with this. Anyway, long time ago I was looking for a circuit. I was looking for a circuit that would work within around the 3 volt range, because with a lot of different technologies like earth battery technology and galvanic action and stuff like that, look at there, 3 volts, 6 watts. That's pretty impressive for a 3 volt battery. Let's see, I highly doubt this is going to work, but let's plug in looks like a 40-watt bulb, incandescent. I'm sure this is not going to work. And it doesn't. So we know at least we can get 6 watts of LED out of this thing. There's that. Now let me see if I can throw another LED on there and see whether or not I can get that one going too. This question is just to see how far can you actually push these dang things. I know that if we start adding capacitors, we could actually store some power ahead of time and reuse that power in a different way. But there's other things that, because I guess he said these were little circuits that were initially for Nixie tubes, to light up those little Nixie tubes. So Well, killed that one and took that one. Imagine that. That's pretty interesting. So connect that one there. So that 6-watt one must take just a little bit more. Ah, look at that. That's pretty wild. Anyway, it's just a tiny little circuit. And of course, if you've ever been listening to my YouTube channel, you know it's all about high voltage to me. So I'm positive that I can do a whole lot more for a whole lot less with this gizmo right here. This one here is another 3-volt circuit that puts out some serious higher voltage, which I'm pretty sure I could light those LEDs up. That little LED is still kind of slightly lit, but it's not bright. Got a capacitor built in there somewhere. Let me see here. Yeah. Stores a little bit of charge. That's why I like those little bulbs right there. And those are really kind of hard to find. If you ever find some of these, grab them up. They got a little built-in capacitor in there, and even after you shut the power off to it, it'll still hold a little bit of light in that thing. I want to do some stuff with that. I was going to do a video that I called Tesla's Dream, and basically I wanted to use wireless energy to light up an entire little miniaturized town, you know, kind of like those little, when people put those train sets together and send all that energy out wirelessly to each one of the little houses and buildings and such, and even maybe run a little train with it. There was a guy, Deeds, long time ago. I don't know if he's still on YouTube or not. I hope he is. I'll have to look him up. But he did some pretty cool stuff with the Slayer exciter circuits. He was able to get some really good wireless energy transfer with those Slayer exciters. Now, there's a little bit different between an actual Tesla coil and a Slayer exciter circuit. The difference being that it's a higher frequency on there. You know, it's a really super fast acting switch transistor that's basically pulsing that power. And so you're more into a higher frequency with more like a FM radio wave or something like that whenever you're using them Slayer exciters, and the switch is so fast that it's harder to get those things to extend out farther as far as distance wise. But I'll just put that over there for a second. Gotta be careful with this dang thing around the dang cameras, because the frequency will literally interfere with the camera and make it all fuzz out, and actually has done some crazy stuff in the past. But you see that this is the Slayer exciter circuit. It's real simple circuit on there. Let's see if I can get a close up on that. Didn't want to do that. Was glued to the board there, I thought. Anyway, it's like a tip 42C transistor, resistor, and a couple diodes. That's it. No big deal. No major deal at all. It's a fancy little circuit. G. Bluer, I guess, was the guy's name that did that circuit right there. But guy named Ryan Abrams actually wired this coil. Of course, Chris had these circuit boards made up, which was pretty cool. And this is a little wireless energy circuit that I put together that he also made some boards up. You know, when people come together, they can get a lot of stuff done. We could have took these things a lot farther. It's a story for another day, but anyway, moving right along. My whole thing is to see how far can you push the limits of something like this little circuit right here? Talking to me or the cat?
Yeah.
I want to see how
noisy. I don't want her waking no one up.
Want to see how far we can actually push that, you know? That's not bad light. That's not bad light for 3 volts. You know, keep in mind there's LED flashlights out there, 3 volts flashlights that pretty doggone impressive. But nonetheless, it's still a really super small circuit. And if you really take the time to look in there, I did a video way back, and I took a hard drive motor and I spun that hard drive motor up with a Dremel, and I was able to use that hard drive motor as a generator, and I was able to light up, I don't know if you can see it or not. I'll try to spin that around here. Get off the ceiling. There's a strand of LEDs that goes all the way from there all the way around over here, and I was able to light that a strand of LEDs up with a hard drive motor. And I was trying to tell everybody, I said, look at this here. Look inside there. There's hardly any copper wire inside this thing. And there's a really weak ring magnet in there. And yet I was able to light that whole entire thing up. You know, and there's some wise guys was complaining, oh, well, you had to put more energy in than you got out. Look, dummy, that's not the point. The point is there's just a tiny bit of freaking copper wire there. All right, teeny tiny bit of copper wire. It's not like winding a big coil like this one right here. It's a little 1-to-1 transformer. Eventually show some pretty cool stuff that you can do with that as well. But I don't know that I'm going to do that today. I might just try it just to see what happens, kind of thing. Yeah, let me do that. Let me see if I can just as some people like to call it, tinker a bit. All right, let's see if I can clean up a mess going on here. I got too much crap in the way. Sometimes you just gotta do it, man. If you've got an idea, just thinking about it, just try it out. See what happens. I've burned up a lot of stuff doing that because I either overpowered it or whatever. I'm gonna try something here, just for giggles. I'm gonna run this. Let's see here. Gotta check something out here. Can't remember which one of the wires was for which. Ah. Okay, maybe that's how I had it. Yeah, I got one way I can find out. Let's do this. See if I can shock the living piss out of myself. Wouldn't that be nice? Wouldn't that be humorous? Huh. All right, well, if you're listening in on the radio, I'm trying to be a little bit more explanating about it. I'm trying to take a little tiny circuit. By the way, Thomas is streaming over to Rumble if anybody wants to go over there and jump on that and watch the actual video. But we'll have a video up after the show. Okay, so that's not the one I want right there. It lit it up. That's the one I want. I'm going to try to run this in series. Let me see here. From there to there. All right. Think, man, think. Oh, okay. That's what I need to do. I need to swap that. I'm afraid I'm going to get myself lit up. All right. Yep, I just got myself lit up. Mighty nice. All right. wasn't terrible. Let me see something here. Okay. Go back to here for a second. I bet done blew it. Nope, I didn't blow it up. All right, good. Trying to get this thing to run. Try to remember how the hell I had this thing wired up. This damn core. Should be making contact yet. So I need over here. There. Now, that should be the one. There. Yeah. There we go. That's where I wanted it. Ah. All right. I'm trying to run this core. You got two separate windings on there. It's like a one-to-one transformer on a ferrite core. And I'm trying to run these wires parallel with each other, essentially in series. Somebody want to add Ted in there? Let me try to just see if I can add him in. Dang it. Add participants. This ain't very good for radio. Ted, try to call in and Ted. If I can find him. Oh, doggone it. Come on. Hold on. This is crazy. Dang it. Yeah. All right. Copy to clipboard. Somebody talk for a second. I'm killing the radio. Dang it. Where are you at, Ted? Throw him a link in there. Paste. All right, there we go. That's why I need a cameraman. So we got to do all this stuff right here. So now let me get back to what I was trying to figure out here. I'm trying to see how far I can push this little circuit. Anyway, like I was saying before, I was rudely interrupted that that ferrite core has two windings on there. Instead of using one as a primary and as a secondary, I'm just running them parallel with each other or kind of in series. Let me see something here. Ow! Jesus! All right. Have we got light yet? Nope. No light. All right. It ain't working. It's not doing what I wanted it to do anyway. Try it before you deny it, man. That kind of thing. Let me see if this thing's even working. Yeah, that's working. All right. Okay, so the capacitor's killing it on the way in. Ted, click on that link, man. Hold on. I got to try to add Ted back in here. Brandon, are you there? Y'all killing me, man.
Oh. Can you hear me?
Yeah, I can hear you now. I'm trying to add Ted in here. I sent him a link, but he ain't He's not picking it up. And this thing ain't showing him in there.
Hmm.
You got Ted in your contacts?
Let me see. How can I go back to that? Let's see, Ted.
He tried to call just a second ago. Click the link, yo. All right. I'm trying to get him. Trying to get him. He wanted to call in. I guess there he is. Finally. Yeah, killing me.
Shazizz, morning.
How's it going?
Doing great.
Trying some crazy stuff. I've already shocked the piss out of myself once.
Oh, great. I don't know what you're up to because I just got online here. I haven't had no internet for a while. I'm sitting in the gas station getting some internets, and I just wanted to check in, see how y'all are doing.
Well, I think we're doing all right. Weather-wise, how you doing where you're at?
Oh, we're getting hammered pretty good, and but to be honest with you, we're at an elevation where this whole rainy winter so far has just been rain dust. But if you were to go about 10 miles, maybe 20 miles, east from me or south from me, a lot of snow the whole time. So it's been good for some people, but it's been kind of, I like the snow and the cold. So, and I'm a gardener, so I appreciate the freeze.
Cool. All right, well, I got to light the light again. All right, so
you can sled riding. You got any hills over there that you can sled ride where you're at?
Oh yeah, there's a few hills that if I wanted to go sled riding, I could. But
No, I'll let you know something. In other countries, it's still perfectly fine for an adult to go sled riding. I went to Europe once when I was like in high school, and I noticed that they don't stop sled riding at a certain age. They sled ride. The older you are, the more you like sled riding over there.
Yeah.
They call it something else. I forget what they call it. They don't call it sledding. They got a different word for it.
Well, right now it's too doggone cold for me to even contemplate, man. So I don't like being cold. I never like being cold. I wouldn't make it good up in a place like Alaska or someplace like that. Canada, all I can say is anybody who can live in those kind of environments, they're tougher than I am. I wouldn't mess with them. Anyway, so there's two AA batteries right there that are running this tiny little circuit. This is one of those Nixie tube circuits that Chris brought over. And just for giggles, I'm just slapping stuff together just to see how far I can push that little circuit. So I've got these running through to a ferrite core that I wrap together. It's like a 1-to-1, but I ain't running it like from primary to secondary. I'm just running it to where it's in series each side. I got like the primaries coming off of one side, and then the other primary or the secondary on the other is going straight into, so it's running parallel, if that makes any sense to anybody. And I just wanted to see whether or not that ferrite core would pick up any with the wireless AC tester. I know this thing's working, but it's not doing anything. I'm not getting any kind of AC signal off of it at all. But it's only a couple cheapo AA batteries that's actually running that. And earlier when I tried to connect a second light bulb to this thing, the one dimmed down. So let's see if I can do it now that I added a capacitor. So anyway, I mentioned earlier that years ago I did one where I took a hard drive motor and I spun it up with a Dremel, and I was trying to show it to people. course, like I said, there were some wise guys out there who were talking about, oh, well, you used more energy than you got out and all that kind of stuff. I said, you're missing the point, man. I'm not trying to say I'm getting out more energy than I'm putting in. What I'm trying to point out is that you got a teeny tiny little copper wire and a weak ring magnet that was able to light up an entire strand of LEDs. And so I think there's something else going on here. That, see, it did it again. Even with the capacitor, it still swapped out. That's still got a little capacitor in there, so it's still holding a little light. I don't know if you can see down in there. Let me do it again. Get down there. See, there's still a little bit of light in there. Yeah. Anyway, the whole thing was I just want to see how far I could push that little circuit. And I'm going to do a lot more experiments.
I think if you wire those lights in series, then they'll both light up.
Well, let's give that a shot. It's worth a try. Get that one out of the way there. Hey, and that little circuit, it'll bite you because I literally got bit earlier.
That's like a little inverter circuit. That's pretty neat. I've actually always wanted one of those.
Yeah, I'm pretty impressed with it. It's a little micro inverter. So the reason why I was interested in those particular, because I wanted to find a, I think I got that in series. No, don't. All right, let me see what I got going on here. Anyway,
did you have to special order that circuit, or did it come out of something you scrapped, or how'd you get that?
No, I didn't order it. Chris actually picked this circuit up, and he brought it over. But they're I guess they're Nixie tube circuits to light up those little Nixie tubes.
What is that, like an amplifier tube, or?
Well, like those. Oh, doggone it.
Nixie tubes, they've got letters and numbers inside of them that filaments light up to change the lettering on them.
Yeah, like neon bulbs.
Oh, okay.
Anyway, doggone it, man. I think I got that ran in series, and it's still not. Well, yeah, it is actually got a little bit of light in there. I don't know if you can see that. God dang it! Come on. Ah. All right. You can still it's a little bit in there. I don't know if you can see that or not. Can you see it?
Yeah, I can slightly see it glowing a little bit.
Yeah. All right. Well, that's interesting. I just, like I said, I want to see how far I can push those little things like that. Now, where in the heck was this at? Stick your tongue on it, man. And it's interesting, though, when you put this on there. I want to see something real quick. I want to try to. Where do I need to be here? Put it here. Ta-da! I want to see if there's anything going on in there. Nope. Ah, series. You was right on the series one though. Anyway, it is what it is. Pretty impressive though for 3 volts. You know, I know you got those 3 volt DC flashlights. I get that. You know, but there's something else going on here. And I think that if you actually had a bunch of these, you could do some pretty cool stuff with it, you know. So I'm gonna do a bunch of experiments later on with that, and then I'll share whatever I find out, and I'll get back to everybody on it. But that's the hard drive motor. If you take one of those things apart and you look inside there, there's hardly any copper wire in there at all. And normally to build a transformer, for 120 volts or something like that, you're going to have quite a few windings on there. It's just a little teeny tiny deal. Now, once again, I understand it's just LEDs. It's not nothing to brag about. But some of the experiments that I've done with these systems back here with these capacitors over here, I can pulse that microwave oven transformer with a small amount of power, and then I can start charging this entire system up through all these different types of capacitors, having them bleed over to each other. I got AC capacitors in there, I got DC capacitors, boost caps and super caps and all those. And I can equally distribute that power out by dumping it into one tank. The big, this big white one right here, that's, I don't know if you can even see that. Get my pointing stick. That big white one right there, that's just a straight up DC capacitor. And I just use that as a tank. And then it bleeds over to all these other ones on there. I got all different types of capacitors. I want every doggone capacitor you could possibly think about. And there's a lot of different things that you can do with these different types of. Where am I at? We've charged it up with this right here. Is another 3-volt one right here. Let's put out some higher voltage, yet even higher voltage on that there. But this is a pretty impressive little. Look at the difference. Dang, I need a cameraman, camerawoman, whatever. If you could hold her steady, that's what I was talking about. Look at the. See if I can unplug this damn thing and put it right up there by the deal. I'm gonna try to find. I know they're on. I know you can get them online, probably on eBay. I'm gonna try to find a bunch of these, and I'm gonna build a whole board with them. Look at that. Look how tiny that sucker is. And it shocked the piss out of you too, man. You're not going to be getting a lot of current out of there. It's obvious, and that's I don't give a crap about current right now. All right, you can always get that back later. We'll cross that bridge when we get there, because voltage is pressure, and voltage is what gets work done. You get a lot of current, you can shove a lot of power to something, but I'm telling you, folks, we're overpowering everything. These transformers and electric motors and stuff like that, they're getting hot for a reason, because you're shoving too much power to them. Many years back, I don't know if anybody's even still doing it anymore, there were some alternative researchers that were tuning electric motors, where they would literally use capacitors to tune these motors and get them to run off of, instead of 120 volts, they could get them to run just as good off of 90 volts. And these motors weren't getting hot.
Right. You're talking about the rotoverters. I've seen a lot of experiments. I actually have a rotoverter, believe it or not. It's a 3-phase motor, but they run the other phases. They make like a virtual phase, we call it.
Yeah.
Or you can single phase motor too. Just like any motor that has a start capacitor, run capacitor, whatever. They don't really optimally tune them. From the factory, they just tell them where they're just going to start, and that's it. They're not actually tuned with the right amount of capacitance to be the most efficient running, that they could possibly be. But yeah, that is very interesting too. What you brought up right there.
Yeah. Well, and there were some that were literally taking the motors, and they would like have a 3-phase motor, and they would set this thing up to where it was one section of it was almost like an alternator. So they'd run two phases to run the motor, and they'd use the other one to pull some power off of that thing.
Yeah, exactly. It's like a rotary transformer, a rotoverter. That's what they would call it.
Yeah. But anyway,
The cool thing about that is there was a guy named Doug Conzen, and he was messing with rotoverters. I've seen a lot of videos of people doing it, but he got his rotoverter to run for like, I think it was 5 or 8 minutes, something like that. Like after he unplugged it, the actual 3-phase motor would run for about 8 minutes without being plugged into the wall with quite a bit of torque still. Like, slowly winding down. But nothing more than just capacitors and the motor itself. That was it. Now imagine if you were just fill up that capacitor momentarily and disconnect the power, from the motor, and then just let it spin a generator, charge up a capacitor bank, and then dump some more back into the, and you just see how long you can keep that going. But yeah, I thought that was interesting. Very interesting.
There was a guy that built a huge generator, and it had a massive flywheel on this thing. And once you got that thing up to speed, you could shut the power off the input, and it would take that force from that flywheel, and it would keep putting out power. That's what I'm talking about. I want to try to see how far can you push the limits of efficiency. If you got an internal combustion engine and it's only 20 or 30% efficient, if the majority of the fuel you're pushing out the exhaust pipe is basically going to waste, then there's room for improvement. So what could we do in that whole entire process from the time you start that car all the way down with everything from the heat losses to any losses in the system whatsoever? How could we monopolize on the losses in the systems? Could we recapture every bit of that exhaust, and refine it back into fresh fuel again? I was talking about how you could run one engine off of the second engine's exhaust, and Garage 54 in Russia, I think they're either in Russia or Ukraine, one to two. Well, it's the same place. They're all Russians. Anyway, nonetheless, they did it. They took one Lada and they ran the exhaust into a bubbler, and then they run that exhaust out of that bubbler right straight into the intake of a second Lada, and they ran that second Lada off of the exhaust of the first one. So I knew it was possible, but finally somebody actually tried it. They did it. And, so now you talk about efficiency. You see what I'm saying? If you're able to run a second machine off of the waste of the first machine, you see what I'm talking about? And so the same thing applies with electricity. Right now it's cold as crap outside, and I don't have a little what you call it, the damn space heater going right now. It's a little chilly in here, but as time's going by, these computers, the heat off the back of these computers are starting to warm this room up in here. You'd be surprised at how much heat literally comes off the back of those computers, monitors, lights, or whatever. It's all otherwise wasted energy. And that's what I'm interested in. I don't care about the current watts and amps. I don't care about all that kind of stuff. I care about voltage. Voltage is pressure. That's what gets work done. And I care about the losses in the system. I want to know why there's a loss in this system. Is there something that you could do to the transformer core to reduce the eddy currents that's causing the heat or whatever? The difference between a laminated iron core and a ferrite core. There's a difference in there on how these things function. Whether or not when the magnetic field is saturating one, it's one will hold it a little longer and the other one will release it faster, so you can get maybe a higher frequency out of this one here than you could off of this one here, without this one here getting screaming hot because you couldn't run it the same way. So there's a little bit of knowledge in there that we can work with. Ah, dang it, man. Trying to drop everything under the sun. But this is an impressive. Let me see if I can get it focused in out there. Look at that. Isn't that impressive as crap? That's some technology. And I'm telling you, Go ahead.
I said I like that circuit. I would like to have one of those up.
Yeah, look up Nixie tube circuits and see. It's a little mini inverter. You know, I hadn't really taken around with it much. Chris brought it around a long time ago, and it finally got around to checking this thing out. But it reminded me of the hard drive motor, and I spun that hard drive motor up with a Dremel. Of course, once again, you know, the naysayers out there going to holler about, oh, you put more energy in than you got out, and you're not going to be able to run your house with that. And I didn't say you could, you idiot. I was just trying to point out the fact you got just a teeny tiny bit of copper wire in that sucker. And then you got that little weak ring magnet in that hard drive motor. There's something to learn from that. You know what I'm talking about? Now everybody leave me hanging like a trombone.
I'm still here. I don't know who else is here. Was there Tom, Ted, I think.
Right, and I also showed this little motor generator right here. I think if you scaled this one up right here with some those big old ceramic speaker magnets, the round ones like you got on the back of a speaker.
Right.
If you took this thing apart, the coil that's behind there is running this way, and so you're not. I don't know how to explain this. It's like a pancake coil in there almost. You know?
I know exactly what that is. The microwave synchronous motor.
Yeah, I took all the gears out of it and I mounted it to a little 12-volt electric motor right there. It's like out of a cordless drill. So I want to see, because when I first saw this, I saw this guy who was on YouTube, and he would crank this thing over and he drops it and it's like it shocked the living piss out of him. And I said, oh, it couldn't have been that bad. So I got one and I spun that sucker around and it lit me up, man. I was like, damn, that's got a lot of power to it, right? And so I was curious to whether or not I could actually take and make a mini generator like that. And this thing, you could hook a 9-volt battery up to it and it'll put out, I don't remember what, probably about 60 or 70 volts or something like that. But let's see if I can. Well, I could hook the 12-volt light, or 12-volt deal up and get that going. Ah, dang it, man! I done put all that stuff over there out of the way. It's about ready to move on. We lost Ted. He must have got bored. Ugh. This is a little 12-volt, 1-amp battery charger. Not very impressive. We'll see something here. Urgh. Everything's cluttered up. Come on, man. Trying to plug it in with one hand. I'm fixing around to get electrocuted. So if you see my hair stand up, then you'll know I did it. All right, let me get some of this crap out of the way over here. Let's try this again. We know we lit that thing up with a 3-volt light bulb. Three volt light bulb. What an idiot! We lit it up with a 2 AA batteries. So now let me see if I can find the end of this wire without getting the piss shocked out of me. Let's see if I can light this thing up with that. The hell we got going on here?
You know, you wouldn't get the piss shocked out of you if you stop pissing around.
All right. Let me get this out of the way here. What do we got going on? Okay, let's see if I can light that LED up. Must have something wired wrong then. All right, let me check my voltage first to see if this thing's even putting anything out. It's straight off of it. It's going to make a bold-faced liar out of me. That's what it's going to do. Put this on AC. Let me see here.
At least it's not pissing down your back and telling you it's raining.
Well, I'm glad. Disgusting, man.
If it's so disgusting, then why aren't you moving out of the way? The government's doing that every day.
Yeah. All right, so we're getting really? Come on, man.
No.
I think my meter's going to hell in a handbasket.
Not to be negative, but no.
So we're getting about 49 through 50 volts out of this thing.
No, you're not.
Why you always gotta be so controversial, man?
Hey, I can't help it. I'm not trying to be negative, but no.
All right, well, I guess I'm not going to be able to light that up. Let me see if it'll light this other little one up.
Click it. Maybe that'll light it up, light something up.
Yeah, stick your tongue on it. There we go. All right, I got that one. All right.
It's not a freezing pipe out in the wind, out in the winter. So.
Really? All right.
Yeah,
Dang
really.
See if I can get this over here in the same deal. All right. That's a little motor generator there. Ah, there we go. Now I couldn't get it to light up this other one for some damn reason.
Yeah, it sucks to suck.
What is wrong with you, boy?
Ain't nothing wrong with me. Gravity.
Anyway, moving right
Or a
along.
good vacuum cleaner.
Huh. Oh. How far do you think we can push that? Anybody?
Well, from the little inverter circuit. Get
Well,
a 3-volt battery, 3-volt lithium ion, 3.7 volt, or the two AA's in series as your input. 120 volts. I would put that through a capacitor.
the argument.
I'm wondering if you could step that voltage down, from like a 110 12 volt transformer. Actually, as a matter of fact, I don't think it would do it, but I'm quite curious to see what the output of that little inverter would, if it would even do something to your little 12 volt charger you're using there, your automotive charger.
Yeah.
That you were using to power the motor right now, the motor generator. What if you get that and put that on the output of the inverter, the little tiny inverter, and just measure what you're getting on the output of the the positive and negative.
Well, I could run that into a rectifier and then try to This is going to be an AC coming out of this side over here.
You could rectify. Definitely could rectify the output of that little inverter. And if you wanted to, you could, you can actually charge a 12-volt battery. That's not that much amperage. It's not going to damage.
Yeah. Well, I did this video a long time ago called Redneck Hot Tub. And basically I had basically regular sized bathtub, pretty good sized bathtub that I turned into a hot tub. And I used a coffee pot element, a little 110 element. And it would take longer to heat that water up. But then once you got the water up to operating temperature, it took nothing to maintain it. As a matter of fact, after a while, you literally had to shut the thing down because it would get way too hot for you to even sit in the dang thing. So when you're talking about efficiency or even charging something up, like charging this bank up, it might take a little while to charge this bank up, but now you have all that stored energy. And so I want to see what I could do with this right here, similar to what I'm doing back there with that over there. Charging that bank up. It takes me 10-20 minutes to charge it fully up with this little circuit right here. And then what if I doubled up and I had a second circuit that was going at the same time? You see what I'm trying to get at here?
Right. Somehow you could possibly loop it. If you had charge up a DC capacitor bank, take the inverter, rectify the DC, charge up a pretty good size DC bank. Get a step down DC to DC buck boost converter. Run that back to the input of the what do you call it? The little inverter. But also before you go from the output of the inverter to rectify the DC, put a 1-to-1 ratio transformer in between to cause isolation. You don't get like it'll mitigate a little bit of lens for you when you try and loop it back.
I've got a whole bunch of other circuits that I had bought years ago, kind of like this one right here, and this similar to this high voltage one right here. And I got some of the little buck converters, and the boost converters and stuff like that. And so, listening to what you was talking about, seeing if you can step the power up. You see what I'm saying? To run something bigger on the other side or whatever.
Mm-hmm.
Of course, obviously, they're going to say you can never get out more than you put in. I'm not trying to get out more than I put in. I'm trying to see how efficient I can make what I've got in my hand.
Well, like we were talking about the flywheel, right? If you got 3 volts and you're stepping it up to like 110 volts, rectify that to DC, then pulse that into a coil, and put a bunch of magnets on the flywheel like a rotor, and pulse that coil like a Bedini motor, and you have like extreme torque after that flywheel has gone up to speed. And I'm pretty sure with that amount of torque, some pulleys and pulley instructions and stuff, you could run a little DC generator or something like that, or generator coil to fill up a capacitor to run the actual circuit at the beginning. There's many ways you can do it. I mean, many ways you can do anything, but
well,
that would be.
I've always said that one day they're going to accidentally give us a free energy device. They're going to do it accidentally. It's not going to be on purpose, obviously.
Right.
They've already gave us incredible efficiency. There are little solar panels now that you can get, cheapo solar panels, cheap Chinese solar panels. And I did a video, solar flashlight, where you literally could take a candle and put it in front of this and it would light the bulb up. That's pretty damn impressive, just off of the flame off of a candle. And these little circuits right here are getting pretty doggone impressive. I'm really satisfied with that one right there. That's pretty dang cool. I'm gonna buy a bunch of these things. Yeah, you should look up, get on eBay and look up Nixie tube circuits and see what kind of price tag they got on them.
Okay, I'll check. You know what I found out? You know what I found out? You know, I did an experiment. You know, over the past couple of days, I've been doing some experiments. But I mean, it's nothing new to anybody who does this. You know, experiments with Bedini stuff, but yeah, I found out you can use a transformer. You can run a transformer as a Bedini oscillator, kind of like a Bedini motor. Off a normal Bedini SG circuit, you could just run a transformer, kind of like a Joule thief.
Yeah. Well, all of those, especially the Joule thief one, where you could pull most of the power up out of that, even when that battery's damn near gone, you can still get it to do some stuff. You know, I'm telling you. You're going to find the right configuration one day, and it's going to surprise the crap out of you. You know, I don't believe that I don't believe that perpetual motion's not possible. You know, in a closed loop system, maybe. But even at that, who gives a crap? You know, Lid Motor has made these little tiny motors, and they're like super efficient. Some of them he's had running for years. And they're just little tiny motors. And so I'm thinking scale up, scale down kind of thing, you know? And even if you had to use an outside power source, like when I did my Free Thinkers video, that thing ran for 4 freaking years. It was all made out of junk. It had solar panels laying in the dirt that were still putting out power. It was just grabbing up power from everywhere and just putting it into a bank. And I don't care whether it's whether you can label it as perpetual motion. You know, if you're using everything that the environment has to offer, you got hydroelectric, thermoelectric, solar power, wind power, whatever, you know, all of it running together into feeding in one system. You might have 3 sources going in just to run your house, but if you got 3 sources going in, something's happening at all times. You know, and so you're pushing it, you're storing that power up for later use. And if you can store enough of it, literally you could build a lightning bolt in a can. You know, imagine a 50-gallon drum.
What a capacitor is to me. That's what a capacitor is.
Imagine, yeah.
It's like Joseph Newman. It's like, I've seen videos where Joseph Newman took his big Eureka motor and he ran it on several, you know, used or dead 9-volt batteries in series. And he also, you know, ran it on multiple lead acid batteries in series. But what was interesting too is he ran it off of many, you know, little tiny solar panels, like you're mentioning. And he put them all in series with input to spin a 7,500 pound flywheel and actually do work with that, major work. He ran like a giant water pump, you know, irrigation pump or whatever, off of tiny solar panels, all in series. Imagine that.
I honestly believe that you can get a lot more work out of what energy we've got.
I mean, you want to talk about voltage pressure. That's what Joseph Newman pretty much did with the motor.
Well, taking everything in consideration that you got, you know, you got the force of that flywheel spinning around, and the heavier that flywheel is, once you do get it up and going, it's going to take a lot to stop it. You know, like those old merry-go-rounds that are made out of iron that we used to ride when we were kids.
Yeah, flying off them too.
Yeah, if you get that sucker up and running, and even if the wind dies down, it's still built up enough force that it's still pulling it around. And then the wind kicks back up and gives it another boost or something like that. That's what I'm talking about. How far can you push the efficiency? That's what I want to know. You know, is it really possible for a man to design a carburetor to get 300 miles to the gallon? Yeah, I'm positive it is. You know, and if you can get 300 miles to the gallon and you don't tell the man about it, then you don't got to ever worry about it. You know, Stan Myers with his hydrogen technology. You know, he was running around in the 70s with a freaking dune buggy, running on water. You know, and
Yep.
they wanted to give him hell about it because his terminology didn't match what the school book said. Now, to hell with your damn terminology. You know, to hell with your school book. Try it before you deny it. If it freaking works, it works.
Yeah, Stanley Myers was amazing, man. I've listened to so many of his videos. I have a lot of his content. I remember downloading his entire estate, which is all the pictures of his devices that they took after he had passed away. But yeah, man, he invented a free energy device just to actually be one of the things that actually make it possible. But it was like this. I remember this guy. Russ RWG, right? Or what's his name?
Russ Grease.
Yeah, that guy. He replicated a lot of Stan's stuff. I remember watching that a long time ago when I was learning about Myers when I first got into it.
I like
But
Russ.
Yeah, Russ is awesome, man. I've never got to talk to him or anything. But I've watched a lot of his videos in the past.
Years ago, he used to come on the Mad Science Show with us all the time, and he's the guy's got talent, man. You know, and there's a lot of people out there that's got some serious talent, and those are the ones you want to bring to the table because if you can get all these people together on any given project, you imagine how fast you could whip out a project. You know, get it done, try it out, see how it works, that kind of thing.
Yeah, that guy can fabricate pretty much anything you want with his shop.
Yeah. Old Thomas here, he might be a wise guy once in a while, but he's got a lot of talent too. But the things that I've seen him accomplish and the knowledge that he's got in things like chemistry and stuff like that is really impressive. You know, Thomas is a valuable asset, even if he is a wise guy. He probably went to sleep already. Jive turkey. Ah, he's back. See what I mean? You gotta keep your eye on that dude.
Well, we're talking about sleep. I'm not gonna lie, I right before the show started, I took a Tylenol PM, and I'm getting a little sleepy, but I'm gonna stay on as long as I can, just because I didn't want to be a party pooper and not participate in this. But it was a long night for me. It was a long night, and I haven't slept much, so yeah. But it's okay.
This doggone battery or the voltmeter I got sucks. When the battery starts getting low on these things, they won't read right.
Right.
Let me see if I got another one that's got a better battery. I run that little deal down through a rectifier. I want to try something out. Error. I got that little circuit over there going again. I got it running through a rectifier. I want to see what's going on here. Dang it. Seriously? The weather has swelled up my drawer over here and I can't get it open. Don't you hate it when that happens?
Yeah.
Come on, man. Killing me. It's terrible for radio. You know, people they can't see what's going on. They want to hear what's going on. What's happening, man? Speak to me. All right. There's one. We can probably utilize this one right here. Now we're putting 3 volts in. Let's see what we're getting out. Yeah, Up wires. Three bolts in. Run it through this rectifier here. All right, now where's the other wire? There it is. Really? Ow! Son of a... All right, what's going on here? I'm not getting no voltage. And I know there's voltage going. What is happening? Oh, I got over on the AC side, no wonder. It's showing I'm getting 160. What? You're crazy. No way. All right. All right. Look at this. See that?
169 volts. DC, right?
DC. Ah. That's
What do you?
yeah.
So
I'm
you
getting
got the inverter circuit.
yeah,
You got the 3-volt battery powering the inverter circuit. Then the output of the inverter. Are you going through that isolation transformer?
no. Oh yeah, I am. Yeah, I am. Let's take it out of there.
And then after that, you're coming out and going into the bridge rectifier and converting it to DC.
Yeah. So it's showing I'm getting 169 volts, and I wasn't expecting that, but when I touched that doggone thing, it lit me up.
Sure, yeah. I mean, that's a lot of power. And now you can actually charge a pretty decent size, like a 200 something. You got a large DC capacitor you can put on that. Big, like a 250 volt maybe. I mean 450 volt. Yeah. The bigger in capacitance, the better.
Nothing that I ain't used, nothing that I'm not using right at the moment.
Okay.
Dang
Because
it.
if you can charge up a capacitor, a pretty big capacitor, DC, you can actually run. Attach your load to the capacitor first, like a DC motor or something. Then connect the 169 volt into the capacitor, and it won't charge up any more than the load can. The load's going to bog down. It's going to kind of like regulate the voltage, but you'll have some decent current powering the load at the same time, which whatever you want to power.
Yeah, I really didn't come prepared for this. I just on the fly I was thinking about that damn little circuit and wanted to check a few things out, but yeah, I'm gonna buy some more capacitors and see how far I can actually push that. That's pretty damn impressive, dude.
You're right. Yeah, that is.
And like I said, I don't care about current right now. I'm not worried about the current. I want the voltage, and I want a high voltage power supply that won't burn up really easy. Like these. Where'd it go? These little things right here. If you feed them back on each other, they'll burn themselves out too easy, and I don't want that. I want to be able to charge something up through maybe a spark gap or whatever, and move that power away. So I want a high voltage circuit that won't, destroy itself. Now the Beckett oil burner igniters, you can take 12 volts to 2,000 volts or no 20,000 volts, 12 volts to 20,000 volts. All right, of course it's in the milliamp range, but nonetheless, that's more than enough to energize that gas into plasma. Like the plasma reactor video that I was working on. I think I had to.
Right. Yeah, like I've actually taken like the output of the Bikini motor, put it into the primary, oven transformer, and you get, you get really high voltage on the other side.
Yeah.
Actually done an experiment where I took the output of the Bedini motor and I took like 4 microwave oven transformers and I put all the primaries from the output of the Bedini in series. So like, you have like four microwave oven transformers. You've got one end going into the first transformer, then it goes in series and series and series and series to the last. Then you got the other output of the Bedini going to the other end of the last transformer. So you get all the primaries in series, and then all of the secondaries with all the high voltage, you can combine those in parallel, or however you want to do that, or run a load off of charge up capacitor banks. You can do a lot with the output, but it doesn't really affect the input of the Bedini motor when you run them all in series like that, which is pretty interesting. I did that years ago, actually. I haven't really explored too much on that, but
I'll try not to shock the piss out of myself, but I want to try to get a voltage with this this neon bulb on there. Okay. All right. So I got like 139 volts with the neon bulb on there.
oh wow, really nice.
That's pretty damn cool. For a little bitty tiny circuit like that, I'm impressed.
What is, if you can, what is the voltage on the input battery right now? I'm running it.
Hold on, let me see. Okay. Must have read that wrong. .58.
It's dropping pretty slow then, huh? That's pretty good though.
Yeah. Yeah, so that's what I'm talking about. I want to try to see how far you can push that, a couple little batteries like that. Charge up a massive bank of capacitors. Time it out, how long it actually takes for those capacitors to fully charge up, and then move that power over to something else and see if you can run something big off of it. You know what I'm saying? You know what I'm saying?
Yeah.
So if you got some stored energy, and you could turn around and run this sucker here again, while that energy is being used, you got a surplus of energy all the way already loaded up. You only need to be able to pull the 3 volts off the dang thing. You know what I mean?
And I don't know if you know, but what is that inverter? Like, what is the frequency rated? Is it a standard like 60 hertz, or is it higher frequency? I'm just curious.
I believe it said 60 hertz on the dang thing. I don't know. No, maybe I
That's
was
pretty
reading. I don't know. Let me look and see. I'm trying not to get the piss shocked out of me. It don't say on there. Hold on. Oh, it's actually got it says Omnixie on there, so that's the brand. OMNIXIE. But it don't give a frequency on there.
That's pretty interesting.
Little mini power supply for those tubes. But come on, man. It's like I was getting 130 or 140 volts while this was actually running left over.
Right.
I'm gonna try to
I've
touch
got something I can show real quick.
Yeah, go ahead. Let me
something minute like that, something small.
let me unpin myself and pin you to the deal. Unpin.
Let me just get my camera stand real quick.
Seriously, come on, man. Get off of there. Now, just out of curiosity, this curiosity seems to kill the cat. I'm going to see if I can. Yeah, see, it ain't going to light it up because I've rectified it to DC, so it's not going to light it up. Huh. Cool. All right. Well, I see your deal on there, but I don't see your video. I guess I'll save the batteries on that. Alrighty then. Ta-da. You got no video, man.
Yeah, just give me a second. I was trying to get set up here. I just broke my camera stand trying to pull it out of the corner it was in. Sorry about that.
What in the heck did you do that for? Sounds like something Thomas would do. Huh. All right, so I guess while he's working on that, so I honestly believe that you can get a lot more efficiency out of everything that we're using. We're using too much power to do not enough. And I believe that if it's done right, you're not going to lose any performance, is what I'm trying to get at. You still have the same performance, but for less input.
So you can see here, all this is a automotive relay.
We don't see your video at all.
You don't see it at all?
No. Did you do a share screen or video? Or
Yeah, I mean,
yeah, your video's not coming through.
No, just seeing your face, that little
Oh,
circle icon.
Yeah. Oh, I thought you.
now.
Yeah, now we got it. Now, I thought you was cracking on his face, Thomas.
No, I only do that to you.
So what you got?
So I put it down to 12 volts here.
You got a flyback driver?
So you got that neon lit right there.
Yeah.
And all this is automotive relay.
Oh, yeah. Yeah, catching the flyback off of that relay.
Yeah.
Yeah, I did that with a tattoo gun too.
You got a little LED bulb there. Let me see if I get some wire leads. Hold on one second.
So if you could take these little deals like this and with the 3-volt input be able to charge up a massive bank, and you had a couple of them working at the same time, and then the switch, when it got to a certain amount of power, would then transfer that power back into the opposite one. You know what I'm saying? Like you got two identical systems sitting beside each other, and you feed the output off the power bank on the opposite side to the opposite one.
You can see that, right?
That's pretty bright. How many volts are you putting in there?
just 12 volts at 40 milliamps. 40.
That little relay's awful quiet too.
It's pretty loud on my end. I don't know
Yeah.
if you can hear.
Oh, I can now.
I mean, the higher you go on the input, the lower the amp draw gets. The input voltage, you see that?
Yeah.
I'll go up to like 20 volts. You want to burn that thing out. Yeah, about 20 milliamps at 20 volts. More output. And this will get more efficient when you put a magnet. You put like a little neodymium magnet in a certain spot. You can get this to run even better.
Yeah, there was a couple guys out there that was doing that as well, putting magnets on the outside of motors to see if they could raise the efficiency of them up.
I mean, definitely you can charge a battery bank, capacitor bank with this too. So we can take that high voltage right there and put it through a full wave rectifier. This capacitor bank, it's a 50 volt bank, 450 volt bank, and I've got a full wave bridge rectifier right there.
Yeah, I like how you did that. That's
so we're gonna take this. It's like that circuit you have. You can put the output of that circuit you have into a bank like this and charge it up. Look. So now I'm charging up this bank, and look at this. Look about this power got.
Did it weld it?
A little bit.
How long does it take to charge it? There you go. I saw that spark. Huh.
Ooh.
There you go. I heard that one. Huh.
Saw that?
I'm telling you, man, capacitors are going to replace batteries one day.
For sure. I mean, you can even get now you can get the capacitor and run this little motor off of it. Now I have the capacitor turned off, but once I flick the switch, it's going to charge up and you're going to see a little motor turn on. We get something like a little flathead screwdriver. So now that motor's running.
Yeah, just put a piece of tape on there. You'll be able to see it whenever. I can see it moving. Well, see, that's the kind of stuff I'm interested in. I couldn't care less about whether it can run your house or not. I don't give a crap about that. What I want to know is how far you can push a little input, how much you could actually store with it,
Right.
The question would be, how long would these batteries last if you were just charging up a battery bank, like capacitor bank, like that one there. And, obviously they're going to tell you, yeah, it can't never get out more than you're trying to put in. I don't even want to talk to people like that anymore. It's just wasting my time. Because what I'm wanting to do is to see how far you can push the efficiency of everything. So I couldn't care less about whether it can run your house or not. I'm not trying to claim it's a free energy device or over unity or 0 point or anything like that. I just want to see can I take this amount of power and store enough energy to do something more than what it could have done by itself. Does that make sense?
Yes, sir. I mean, I've done an experiment with just a joule thief by itself. I wish I had that circuit working. All I got to do is just replace a transistor. That's what's been wrong with it this whole time. But it was like the first joule thief I ever built back then. I still have it. But I took like a 9-volt solar panel. It's actually the ones that, how you have those some people buy those solar systems that it's like a little solar panel that charges up like a lithium ion battery, like an 18650.
Yeah.
18650, and it powers a floodlight like outside your shed or something, you know. And it's like a 9-volt or 6-volt solar panel. And I took one of those panels and I put it through like a 30-volt capacitor, pretty big one. And then I had the capacitor powering the Joule Thief circuit. Then off of the Joule Thief output, I was like powering so many things off of it. I was literally charging a phone. I was powering 3 lights, 110-volt lights, and then I was charging a small 1.5 amp lead acid battery as well. I actually have pictures of that, the way I had it wired up and everything, and that was like I think 4 years ago when I did that. But yeah, man, I was showing people that a lot when I was doing that. Like, look, man, like, you can't even run any of this stuff, you know, without putting it through the Joule Thief or something like that, you know.
Yeah.
Stepping up the power, you know, storing their power, the capacitor, you know. It was just amazing. It blew me away, you know, just that little experiment back then. But I've already found out more ways of stepping up this power. You know, once you put this reactive power or whatever you want to call it, radiant energy into a capacitor, it completely changes. It adds like amperage to it.
Yeah, that's what I was saying. What I was saying was that you know, you can get the amperage back later. You know, use that voltage to pressurize your capacitor, and then see how far you can push it. And we were working on a what I call a rotary cap, which is essentially a flywheel that has you know has built-in capacitors on there, so that as it's spinning around, one half of the wheel is picking up power and the other half of the wheel is discharging power. So it literally takes all the energy on this side over here. Let me just share a screen and I'll show you a diagram of it. Unpin, pin, share screen. All right, so I got to go over here to our podcast page. Scroll all the way down to the bottom. Gotta get you out of the way there for a second. What the hell's going on? Now everything's freezing up on me.
Let me see if I can pull out an old motor that I've had for a little while. It's actually a motor that was built by Sky Collection himself. You know, Sky Collection on YouTube. Let me see if I can find that motor real quick, because I would like to show that.
All right, where did it go? There it is. Open image, a new tab. All right, can you see that?
Yeah, I can see that.
I
think you were showing us this last time. Yeah, you were showing me this.
Yeah, so one side is charging while the other side is discharging. So as it's spinning around, you know, you could have it spinning, you know, real slow or maybe even real fast. And basically the point is to keep the generator from being directly loaded down by the load itself. You see what I mean? To reduce that load on there, you're just going to do, the generator ain't going to do nothing more than charge capacitors. That's it. It's not going to try to run the load. And then once the capacitors, you see there's a split on each side. One of them, the yellow one, is charged up and it's getting ready to go around and discharge, and the red one's ready to be charged again. And so as they're spinning around, you're taking the power off of the generator, but you don't have the generator directly under a load. That's the key. You see what I'm saying?
Has anybody ever built that? Is that like I mean, that's really, really interesting. I like that.
Well, Chris made an attempt to, but it didn't go so well. It was in the manufacturing portion of it, but it's not hard. I guess if you got a 3D printer, you could print up the flywheel or something like that. But I think it'd probably be better off if you used some things like some roller bearings and something to ride that track, or some sort of brushes or whatever. That was the issue. I mean, he did build a prototype, but I don't think he ever got it to work right. So it's still open. There, you could copy that design and try it out yourself and see if you could get it to work.
Yeah, I screenshotted it. I will check that out. And
keep in mind that the larger you have this wheel, the more power you're going to have to be able to store. And you can adjust the speed to wherever you need it. But now you've got a system that you can get power off of that generator without putting the generator under a direct load. That's the key.
Right. Let me show you. Trying to get this old motor out of the box.
All right, let me stop sharing screen here.
Just trying to get this hooked up.
And if you can do that, if you can see, the whole key is when you put a generator under a direct load, the moment you turn that light on, that energy makes its way right back to the same generator and creates a second field that starts acting like a brake on the armature and slowing it down. So the key is how do you separate? You get the power off the generator that you want, and then separate it and get it away from the generator completely.
Right.
And you could even build this into the generator itself, and you could still get your AC wave out the other side, and on that discharge, it might end up being more like a pulse DC, unless you take that discharge and you dump it into a bank and then run a little mini inverter on the other side to put your power back to the AC wave again. But nonetheless, the generator itself should never be under a load. The maximum amount of load is whatever it takes to charge those capacitors. You see what I mean? That would keep that power from being able to go back into the generator and bogging it down. It's like if you go look at a 5,000 watt generator, it might only have 25 or 3,500 watts, normal run with all your loads on there. It's got a 5,000 watt peak is what it says, 5,000 watt maximum output, but you're not getting the full 5,000 watts because the moment you put it under a load, it bogs it down and you're only getting about 3,500 watts. That's what we need to change. And if you did that, you'd use less fuel on the input because it wouldn't be working so hard. That makes sense?
Right. It's like I said, like the Bedini 1984 device or motor that he made. It's basically like the motor and the generator are never connected. The battery is not powering the motor at the same time as trying to accept the charge. Like you're basically, when the generator's off, the motor's on, and when the motor turns off, the generator turns on. And basically, you don't have drag, you don't have lens happening because you're not closing the loop. It's essentially an open loop system.
That's the key right there.
Let's see, I wanted to hook this up. It's a pretty cool little motor here. I'm going to share my screen real quick.
That's my little AA battery thing going on over there.
See this motor here?
Yeah, hold on. Let me pin you back up there again. All right.
So we got this is a pulse motor. They got a bifilar coil right here. And this motor was built by Sky Collection. He's a guy on YouTube, so
Yeah,
you know,
I love his work.
yeah, this is one of his older motors, and I've had this one. I actually just took it out of the case that I had in, so been taking care of it. But this motor is a post motor. You know, you got these VCR heads here, just as kind of like flywheels, but it's coupled to this little DC motor being used as a generator. And we're going to take some of this mechanical power off this post motor and light up this little LED, 12-volt LED bank down here. And this is just the JL94 circuit. It's two of them. And then also with these two 120-volt bulbs, be able to capture the back EMF and light those up. So let's go ahead and do that off of this 12-volt battery here. Right now it's in self-resonant mode, so you can hear the coil humming, right? Those lights are really, really bright. But let's turn it. Hold on 1 second. Let me shut off this, shut off that. Here we go. Takes a little bit. Might be this coupling right here. Give me a second.
He makes things really good. I love his craftsmanship.
It wants to go. Let me see. This battery actually might be a swap battery here. Let's try this battery. I'm surprised. This thing, it's hard to do this with one hand. This thing would just get up and go. Just one spin back in the day, I remember. Hang on 1 second. Wonder why it's giving me.
And that's pulling power off of the little electric motor on the other side. That's the generator portion.
Right. Okay, there it goes.
Cool.
So now it's up to speed. So I'm going to turn on you see the back EMFs coming out of the neons. So I'm going to turn on the lights. See, this is the back EMF right here for the collapsing field, for the flyback. And as this gets up to speed, it'll light up this neon bulb, little LED strip over here. But it might have to spin the other way. The way this is hooked up, I think it needs to spin the other way. Hold on 1 second.
Yeah, that's another thing. If you can control the direction that electricity is flowing in, you know, thinking about like a figure eight, you know, instead of sending the power back in the opposite direction, if you sent the power back in the same direction with the flow, you see what I'm saying?
Right.
That's the thing I think most folks are overlooking when they're going to build these different types of generators. And these little tiny circuits right here, these things are so doggone impressive, man. It's I can't say enough about them. Imagine if you had a whole board of these, you know, at least 12 volts worth. So put 4 of them on there. And I don't know what the maximum input on these things is. I need to check that out. But I know that they'll run off at 3 volts, and so that's good enough for me. That battery ain't no good.
Okay, there we go. It's been a while. I haven't run this thing in months. That's what.
How's you able to speak to Sky Collection? Does he speak English?
No, he speaks Spanish.
Yeah, we need to find somebody who'd be a good translator and get him on the show. Because I would love to talk to that man. Watching the stuff that he does.
I've got a friend, well, like I've said, my friend John. See, this is coming off the generator right here. My friend John, he's the one that lent me some of these motors to experiment with and kind of like take them further than what they're at. Like, this was a while back, but this is Sky Collection circuit right here. And I actually replicated, this is actually my version right here of it, which is pretty much exact replica of it. And he usually makes the single version, which is this one right here. And that's just half of this circuit, pretty much exactly.
Yeah.
And I pretty much made the same exact circuit. That's mine. And like this motor back here, this is my motor that I built as well. But yeah, man, there's been a lot of stuff that's happened in my life on and off where I just, things get in the way. You got to move so many times and you just don't ever have a place to finally like experiment and peace, It's just.
Well, that's the reason why I wanted to try to get the dream team all together, because between the stuff that you're doing and Thomas and everybody that's involved in the thing, and there's other researchers out there that like to get in there. These big companies and corporations, they hire the best of the best out there. And you never see or hear from them again, because everything that they do, they're getting paid good money to do. But the company's making out like a freaking bandit. And that could be us, If we pulled our resources together, we could solve a lot of these problems. I want to see how far I could push this circuit, How long would it take a team of people to test this circuit to see exactly how far could you actually push it? With the things that we want to test. I don't give a crap about all these other people out there saying, oh, you're putting more energy in and you're getting out, all this kind of crap. I don't care about all that. I don't even care about the current watts or amps portion of it. I'm not trying to run my house with it. I'm trying to see how far I can push this circuit to its maximum potential before it fails. If you got a high voltage circuit that won't destroy itself when you're trying to charge stuff up, you can move that power around. You can change them. That's all we're doing is we're speeding it up, slowing it down, storing it. It's not rocket science, but everybody wants to make it more difficult than what it really is. And so with that said, I want to see each one of these and other designs out there. There's people out there that's got some pretty cool designs, and they got some anomaly that they believe that this thing is actually, putting out more power than it's putting in. And so with that said, I want to see each one of these and other designs out there. There's people out there that's got some pretty cool designs, and they got some anomaly that they believe that this thing is actually, putting out more power than it's putting in. And so with that said, I want to see each one of these and other designs out there. There's people out there that's got some pretty cool designs, and they got some anomaly that they believe that this thing is actually, putting out more power than it's putting in. And so with that said, it might be right on the very edge, and it might only take one little circuit like this to throw that sucker over the edge to where it's really doing what they think it's doing. You see what I mean?
Yes, sir.
And these things like that, you can buy that off the store shelf. You don't have to reinvent the wheel on it. So we can get all these different parts. We can test all these different parts, see how many of the pieces of the puzzle will fit together, and see how much power that we can literally take from these two little pin-like batteries, two AA batteries anyway, and see what we can do with it. Because I'm telling you, man, whether people believe it or not, I'm a 100% believer in free energy. And forget all the terminology, the way they want to explain it. It ain't nothing for free. You got to buy this, you got to buy that, blah, blah. I'm talking about if you understand how this energy is actually traveling, and you understand the difference between resistance and other like that. We know for a fact that high voltage can move through the wires without the resistance that a lot of current can. So if you can move that power rapidly enough to charge up a bank to literally run on the opposite side the current that you want, you can move it from point A to point B and get it to come back around and do what you wanted it to do to begin with, and do it for less amount of input. Does that make any sense at all?
Yes, it does. I want to share a picture here. Let's see.
It's like these dang batteries, man. These are regular alkaline batteries. There's nothing major to them. But I believe that we can build these batteries better. You know, I believe we can get more energy density out of these type of batteries and different types of carbon batteries. I threw a deal on a guy's. I can't remember what his name is, but he does all kinds of experiments and such, and he's always asking for ideas in there for a video. If you have a video idea, he says if he uses your idea, he'll give you a 3D printer. Anyway, I threw one out there just for giggles to see if he could build a battery using 2 pieces of wood, and taking those 2 pieces of wood and building a square metal housing around them, and then using pyrolysis to turn those 2 pieces of wood into pure carbon. Basically like you do in biochar. And then take some recycled plastic and build a housing for them, and then put 2 different types of electrolytes. One of them you put battery acid in, regular lead acid style battery acid in, and the other one you use pickling salt. And to see whether or not.
So, I'm sorry to interrupt.
Go ahead.
I sent a picture in the chat if you want to bring it up on screen to look at it.
Start sharing. Share screen. Okay, what are we looking at?
So the battery on the left is the input battery, or the run battery, the primary battery for the whole thing. That's the whole system that's going on. And basically the battery on the left is powering that circuit on the right, which is this normal Bedini SSG circuit. And you see the yellow and the green leads are going into the primary of that transformer right there. And I've got it hooked up where it's like self-triggering. It's in a force oscillation mode.
Yeah.
So it's like basically it's pulsing one of the coils on that transformer as like a joule thief in a way, or like a Bedini bifilar coil and self-resonance, but it's just force oscillation versus oscillating on and off, just pulsing that coil. And you're getting the back EMF collapse field as well, which is also going out. It's going out the output of the SG circuit, and that's charging the battery on the right side that you see as well. So that's that far into the circuit. Now on the secondary of that transformer, on the secondary, we see the white and the green wire. That is going through a half-wave bridge rectifier, and that's charging that big capacitor up right there on your left side, on the left side of the battery. The big blue capacitor, that's a 25-volt capacitor. I forgot how many farads, microfarads. Actually, it's right here. It's 67,000 microfarad capacitor, 25-volt DC, and it's charging that up off of the secondary that's coming off the transformer. And basically off the secondary, I'm able to power off the capacitor. I'm also able to power a second Bedini circuit. So basically for one Bedini circuit being powered off of one battery, I'm charging a second battery off of that one battery. Also off the secondary of the transformer, I'm charging up that capacitor. And it was running around, I remember, about 13.95, I think, between 12 and 13.95. Maybe I've even seen it gone up to 20 to 18 volts, depending on what I was doing to the circuit, like what I was trying to manipulate here and there. But I'm able to power a second Bedini system off that pancake coil on your left side. You see that pancake coil?
Yeah.
And I actually put a rotor, with some real powerful neodymium magnets on that pancake coil, and I get really, really good. That rotor will spin extremely fast, and you get really good torque out of it. I mean, even if you wanted to, I even went further, and I put a generator coil on top of that rotor that was spinning off that pancake coil. Getting even more power out, and this wasn't even affecting the input at all. And I was actually, what I did with the output of the second Bedini circuit, the second Bedini circuit on the left, is I put the output of that back EMF right back into the very first battery that was powering the whole thing in itself. And it was charging it up. It was self-charging. Not fully, where it kept going up and up and up, but it basically, the interesting part about that setup is, like, let's say if the battery was like at 12.40, as soon as I turned the system on, it would shoot up to like 12.45 or 46. And then when I would disconnect it, it would go back down. Usually after you're running a load off a battery, like a little motor or a light, there'll be a recovery voltage where the voltage would rise up to what it was under load. And basically, that's not the case in this sense. The battery actually goes down when I turn the system off.
Yeah. If you can scrape up the pennies to do it, these car audio capacitors like these right here, can you see them?
Right.
Get those car audio capacitors, and for your batteries, get this one right here. This is a combination car battery / capacitor.
Yeah, that's nice. Well, I've got some super capacitors. I've got quite a few. I've got a 3,000 farad Maxwell super capacitor bank, and it's a 16-volt, 3,000 farad.
If I was gonna run my house off of batteries, this is what I would want right here. These things, they use them in like diesel trucks because they got a really good punch when it's cold outside.
Exactly.
Because of the capacitor. But I believe right there that's the key. If you could combine these two right here, you're not going to be wearing that battery out so fast, because it's going to be pulling that load off the
capacitor.
Off the capacitors, and because those capacitors are going to stay charged. And you let the capacitors do the work, and the battery, is basically there as backup power. So it wouldn't take nearly as much as you'd think to keep that sucker charged up. So
yeah, exactly.
If I had the funds, I'd have 1,000 of these suckers.
Right.
They're like $149 a piece. That's what this particular person selling it right here, $149.02. But instead of having lithium ion or nickel cadmium or anything like that, that's got a lifetime on there, I believe that these right here would be durable enough to last for a magnitudes times longer than the other ones because of the way that they're set up. But that's what I want right there. I want those type of capacitors right there. This combination battery and a capacitor. Now you could do this with just the car audios and some regular deep cycle batteries, or even some regular lead acid batteries. I think the deep cycle would be better because if you can only drag those down, the regular car batteries down a certain percentage before you'll mess them up. But with a deep cycle, you can drag them all the way down, I think, to like 20%, and you won't hurt them. So
what about these? If you can share my screen real quick.
Okay,
I've
hold
got
on.
these. This is the ones I was talking about.
Did you put a picture in there, or you?
No, I'm just sharing my screen video.
Oh, well, let me stop sharing mine so you can share. All right.
So this is the 3,000 farad, 2.7 volts each cell, 3,000 farad right there. So this is a 16 volt capacitor, super capacitor bank, and I have the
Yeah, that's
I've had
what
this.
I've got. That's what I've got over here. One just like that.
Yeah, these are awesome for experiments and stuff,
Yeah.
And I've got the smaller ones. I've got the smaller ones that are the 500 farad banks as well. Like these right here, actually. Let me see. Hold on one second.
I'm telling you,
These right here.
these doggone capacitors eventually are going to surpass battery technology. They're already impressive as heck. That's why I was excited when Elon Musk bought Maxwell capacitors, because I thought, okay, he knows what I was trying to say, And
I remember when that happened, and he had made that hybrid lithium ion whatever slash supercapacitor battery.
Yeah.
Because he already sees where the future of battery storage technology is.
Yeah.
And yeah, it is. And what the future of supercapacitors itself is going to be the new graphene supercapacitors.
Yeah, and that's why that carbon battery that I was talking about would be such a good thing. Basically, if you've got a couple pieces of oak wood, maybe half-inch oak wood or whatever, you could have them any different size, and then you build a steel box that you can put around it with a hole in that box, just a small hole, just to let the gases vent out. And then you use pyrolysis to basically turn it into carbon. It takes all the impurities out of the wood, and you're left with essentially biochar, but they're still connected into one plate. Now, because of all you're literally got a super lightweight carbon plate now, and the energy density should be really good because it's really porous. It's like a sponge. You know what I'm saying? Like your regular plates is because you got all the surface area. It's the amount of surface area that you got that matters as far as your energy density goes. The more electrons you can store on there, the better.
There was a guy. You've heard of the channel Quantum Magnetics?
Yeah, I think I looked at it.
That guy, his name was Mike, and he passed away in 2021.
That sucks.
Yeah, he was an amazing guy, man. He made some real free energy pulse motors, man. He was showing the rotoverter technology. That was like the last thing he actually showed before, the unfortunate. But I used to watch the channel a lot. I wish I could have bought his motors, but because he was selling his stuff for his stuff is very expensive, his motors, for in the thousands of dollars to afford anything from that guy. But I don't blame him. His stuff is what it was claiming to be, But he had free energy pulse motors for sale, and there was some guys that have bought them, some channels that I've seen. Anyways, but what I'm getting at is that At the very end, he had made a 16-volt super capacitor bank that was made out of those graphene cells. Basically, graphene. It was pretty much what I showed you, that big giant Maxwell 3000. You know, the same one you have. They
Yeah.
made that, but way, 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 way smaller with the same amount of power density because it was made out of graphene. You know, but yeah, you can check those out on his YouTube channel. He used to have a website, but the website got shut down because, you know, he's not around anymore. But he was like one of the first guys that was showing off that, you know, the capability of that technology. And he had made some really nice super capacitor banks that he was selling. And I don't know if you can look it up on his website. Just go to or actually, no, you can't. I'm sorry, his website's not around. You can go look it up on his YouTube channel, Quantum Magnetics.
Yeah, I'll look it up later, but I'm trying to find this one guy because I want you to see this ion thruster that he made. And dudes, I like watching this guy's channel because he, number one, he has the money to do things and he has the tools and the skills to actually do stuff. And he's done some pretty impressive things. I'm gonna see if I can find that video real quick. But he made an ion thruster and he was getting some really good results out of that thing. Yeah, let me see what's going on here. How many videos did I watch? Trying to go back through my history, see if I can find that dang thing. They're actually gonna work on doing a really super light plane that has a lot more thrust, ionic thruster kind of thing. Let me see if I can find this guy. Oh, dang it. Come on, man. It's always frustrating when you...
Not like where they're taking like high voltage and like making it into, you know, making a thrust out of it.
Yeah.
Where they have like a ring magnet and it's coming out and he's trying to get it to like pulse at a certain orientation or something to cause like rotation.
No, let me find this. The one he did is like ridiculously simple design. I mean, he did it on a 3D printer and stuff like that. But
I think I know what you're talking about. I haven't looked into that.
I can't remember the guy's channel name, or I'll just jump straight over there to it. I'm just scrolling down through my my watched videos, my history, or whatever. It's probably in my liked videos, I'm sure. But I like watching when people do that because you can, you know, the ion thrusters, they've had ion lifters for a long time, but they're really not that impressive. They're super lightweight and all that, but he was getting some serious thrust out of this thing. That's why I'm trying to find it. Anyway,
I mean, it was serious thrust, but his input was probably what, minute compared to what we're doing now.
oh yeah, it wasn't much that he was putting into it, but he was getting really good results. Building and that's not it. That might be the same channel though. Dang it, man. I don't know. I'll find it. But things like that, because I know that you know, that kind of technology in the future, you know, could be really, really impressive as far as, you know, if you want to do, you know, some really cool airplanes that pick up power as they're going. That's what I was always saying, like the Ram jets and stuff like that. If you picked up that atmosphere as you're flying through it, and you could convert that on the fly, you know what I mean? You get hydrogen on the fly kind of thing. Dang it, man. How many dang videos did I watch? It's a plasma channel, I believe is what the channel I'm looking for. Have you ever seen that channel? You still there? Hey.
Sorry, my mic was muted. I was talking. I was replying.
I'm gonna try to find. I think it's the plasma channels. What it's called.
Yeah, I was saying that. I think I've seen the videos you're talking about, but I just don't know what channel it's like or what. I watch pretty much everything, man, related to energy.
Designing the magnetic thruster. Okay, there's two videos on here. Okay, let me try to share screen again. Hopefully my computer don't lock up because it's using too much. You got my video yet?
Yeah, I can see your screen.
All right, this one right here is one where he did the thruster.
Okay, no, I haven't seen this yet.
Yeah.
This is one of the most fun and safe ways to earn.
All right, I don't want the commercial. All I want is the deal. Okay, I'm going to play this and I'm going to run.
That is just next level. The volume on this is insane. A few months ago, I started digging into MHD drives, or magneto-hydrodynamic thrust. It's a super exotic type of thrust that uses no moving parts and is straight out of science fiction. Better yet, producing it is incredibly easy. Like many videos on YouTube show, all that's needed are 2 electrodes, a magnet, and some salt water, plus electricity. For the sake of categories, I call these unidimensional thrusters. So, after physically testing numerous variables, I designed what I consider a 2-dimensional thruster. It showed some potential with speeds in excess of 35 centimeters a second. Like many first prototypes, the design showed some promise, but had plenty of room for improvement. From the magnets and electrodes to the geometry and repairability, it could all improve. After considerable redesign, printing, and testing, I found a solution in the form of what I like to call a 3-dimensional BRM thruster. This video is sponsored by Novium. Okay, so MHD thrust can be used to move water, plasma, or any conductive fluid. However, I'm most interested in its use for marine transportation. Now, we've had propellers since the beginning of time, so what's the point? Well, both gasoline-powered boats and diesel ships emit tremendous amounts of noise pollution into the ocean, which can have detrimental effects on marine life. They don't like that. While they're not perfect, MHD drives might offer a quieter alternative. They also don't have any moving parts, which is just cool. Taking a look at my first MHD thruster, a few design improvements come to mind. For starters, these magnets are metal, meaning they conduct electricity. So when this is submerged underwater, they act as kind of a partial short circuit between the electrodes, robbing power out of the system. This isn't fully submerged, but you get the idea. Next, the magnetic fields on the top and the bottom are fully exposed. This is a big inefficiency because while the main output goes backwards, this exposure causes a countercurrent to flow forward. The nozzle I designed is far too constrictive, it slows output, the electrodes are easily corroded, and lastly, the magnets I used are not the most powerful grade of neodymium. Ease of repair and assembly were also super high on my list as well. So after copious hours staring into space, I realized a radial design might be the way to go. So
that's one of the videos. I'll share the link to it. Everybody can watch it later. But the one I was actually talking about is this one over here. You guys still there? This one.
Yeah, I'm still here. That was watching. It's very interesting.
All right, I'll share the link to that video.
Woo! That's a success. This is both a wing and an ionic thruster in one, and it might just be a step in the right direction. You see, for the better part of a year, I've been trying to optimize an ionic thruster for flight, and after I designed my first BSI thruster, it set in motion a transatlantic battle. Responding across the ocean, my friend and fellow creator Joel designed his own ionic thruster, one which worked really well and quite frankly, outperformed mine. So I bounced back with my BSI Mark II, which moved twice as much air at twice the velocity. Refusing to kneel to an American, Joel responded with a second design of his own, one that was brilliantly simple and compact. All this back and forth, while super great for competitive innovation, led me to wonder if we're even on the right path. Look, to design a no-moving part ionic thrust airplane, which is my goal, we need to minimize weight and components, not the other way around. And maybe the best way to do that is to incorporate ionic thrusters into the wings themselves. Well, I know a thing or two about plasma, and Peter Sriepel, he knows a thing or two about wings. He's built and flown planes for a decade. So after we shared thoughts, I got to work designing an ultralight wing design with built-in thrusters, printing several iterations, and finally arriving at a weight and power that offered some promise. This video is sponsored by CuriosityStream. To fully understand this ionic thrust wing idea, we need to go back a few months to when the days were full of photons, ethanol, and bad decisions. I was watching the Blue Angels over Lake Washington, and in a moment of clarity, I realized that modern fighter jets aren't airplanes with jet engines attached. They basically are jet engines with wings attached. The thrust component is incorporated into the structure of the airplane itself. So I thought, what if we incorporate ionic thrust into the frame of a glider? Glider wings are huge, designed to create lift from really slow speeds, and might offer the best testing platform. After a few cups of bean water at my favorite cafe and conversations with a fuzzy friend, I sketched up something that might just have potential. Wings and airframe design really aren't something I have that much experience in. I do understand the basics, and that's about it. Luckily, when I was at OpenSauce in San Francisco, I met a variety of other creators, one in particular who can make anything fly. And I do mean anything. For example, this is his Dremel-powered helicopter, a leaf blower-powered airplane which actually flew quite nicely, a PC fan-powered ultralight plane, and this is a hand drill-powered plane. He also attempted to build an airplane entirely out of food, which flew for about 17 milliseconds and then tried to fight the Earth. I figured he'd have great insight on how to get this project off the ground, so to speak. Yeah. So we chatted for a bit. You recall the picture that I sent you?
Yeah.
It has to be a glider format, right? Like it has to be a slow-moving big airfoil.
Very slow-moving airfoil, but it's also going to be very low wing loading, but it's going to have a huge aspect ratio. So very, very large wings, large slender wings.
Okay. Would you be interested in coming up with a specific airfoil design or aspect ratio that you think would be best?
I will have some stuff to send your way, at least with an airfoil choice.
Yeah.
Because I want to look at some of those super light urban-powered airplanes that they do.
I want to see if our approach on the top of the wing is better or worse. So.
Okay. This is going to be like 9 out of 10 on the hard scale.
That's good to know. From what I gathered, building a functional ionic thrust wing was plausible, but going to be super difficult. But you know what? That's never really stopped my engineering attempts before. And as this one,
let's skip ahead in this video. Get it down to his last final test on this thing. All right, I think it's right about this area. All right, gonna make me have a commercial, ain't you?
This shingle, it's metal.
Nope, I don't want your commercial. Do-do-do-do. Okay, there we go.
Of thrust and velocity. So, a balance point, an armature, power source and high voltage modules, and ionic thrust wing. Able to move freely from the ground and ready to be tested. Let's give it a try. Oh, yeah. It's working. It's working. This is really, really interesting. God, this is so useful to see. This is so
that is
cool to watch. Just going around and around. That's a success. At max speed, it reached just under 60 RPM, and with a circumference of 2 meters, that's 2 meters per second. Not quite fast enough to fly, but this is only a 12-centimeter section of wing with the wind resistance of 50 centimeters of armature. So essentially, this goes 2 meters per second while dragging along dead weight, which, as I discovered, is really painful to stop. Oh, that hurt really bad. Oh. Okay, here's the magic. Excluding the 202 grams from the base, the armature weighs 522. 75 grams of that is the arm itself, and the rest split between two masses, one being 175 and the other 231, plus a balance weight. They both rotate about an offset center, with one arm being 29 centimeters and the other being 22. The wing's final velocity is 2 meters per second after 12 seconds of force being applied. I tried to calculate the thrust for over an hour, and after a few close attempts, ChatGPT had it pinned at 44 grams. Honestly, I went through tons of iterations, and this wing segment can be improved further. For example, using a higher current power source will increase velocity output, and using wire instead of razor blades will shave off more weight. I plan to incorporate these changes when I build out the full ionic thrust wing. Make sure you subscribe to be kept up to date, and leave your thoughts on this video down below because I love the feedback. I'd like you to ask yourself, is it possible we're on the precipice of a new era of flight? A solid state airplane. It's something that I'm super...
All right, well, he's got a bunch of different stuff like that. I love his channel, you know. The difference between
I saw the Tesla coil stuff he did back a while back. That was like the first stuff. Yeah, that's amazing, man. That's pretty damn amazing. I've never seen that. Thank you for sharing that.
I'll copy this link too and share that one so you can watch the whole thing uninterrupted. But yeah, I go around and I look for people like this all over the internet, and hope to get some of them on the show eventually. If you could get all these kind of guys together in a lab where they had all the resources necessary to, if they had an idea, just build it, you know, try it before you deny it kind of thing. And, you know, I don't want somebody's going to sit around and tell me, well, you can't do this because it violates this law of thermodynamics or whatever. I don't want to hear that. You know, the laws of physics aren't written in stone. We're still learning new physics. And so if you got an idea, you won't know it's going to work or not work unless you try it. You know what I mean?
Yes, sir.
So I want to hear what even some people would classify as a stupid idea. All right, if you call it a stupid idea, build it exactly to the specs that this guy's or gal's thinking, and show me where the flaw is. Might very well be a case that where that flaw is, we've got an off-shelf part that you could put in there that would solve that problem. What do you think?
Yeah, I mean, I think anything is possible. I agree with the speculators, the people that say, you can't do that because conservation of energy says you can't get more than out than what you put in, and I don't go by that. I just go by,
Well, we know for a fact, irrefutable, we know for a fact we can get out more voltage than we put in. We can amplify that voltage to God knows what.
Yeah, I mean, Tesla's even said that himself,
And voltage is pressure.
You know to multiply voltage. You can multiply voltage to infinity if you want, as many times as if you can possibly do it. But Tesla was very good at doing that. And I guess one of the ways is to do it is to make as much voltage as possible, and then step it down and get the frequency down, step it down, and that's how you bring the amps back up, and that's how you get your power back,
I'm going to share screen one more time, and then we need to start working our way up out of here. But
yeah, so I mean, honestly, man, I know I got to cut it short today. I went it longer than I actually could. I'm really tired right now, shazizz. I'm going to be honest. I had took a Tylenol PM before we started, and it's hitting me hard. It's been hitting me, so I gotta get off here because
okay, give me just a second before you take off.
Okay.
All right, let's say hypothetically this is a 50-gallon drum, one of the big old plastic 50-gallon barrels, and you can have some disc cut, and one side I have a hole about that big, just big enough to thread in a big piece of all thread, and the other side I have a much larger hole so that the other side doesn't get there's no contact. All right, and then you take this and you copy it. Copy it. All right, paste, and then let's say this gray one that I'm about to make gray here. All right, that's glass. Undo. So you have some glass cut like this right here. Dang it. Need better eyeballs. All right. So this one right here is glass. All right.
Okay.
This one over here would be aluminum. And they're going to fit right down inside this 50-gallon drum. And so you start off stacking these. You put you put aluminum one. Let's just do that. All right, so you put aluminum one, aluminum plate, and then you put a glass plate on top of that. Stop it. All right, so you got aluminum, and then you got glass. All right, and you rotate these. You flip them from. You see where the hole is?
Yeah.
You rotate them back and forth all the way up this deal. And then, so basically inside this copy, paste, let me see, transparent. All right. All the way up and down this 50-gallon drum. Copy, paste, paste, paste. Might be able to get one more in there. All right, so this 50-gallon drum is set up like this. And then you have a piece of all thread. We'll just call this all thread. It goes all the way down. That's your contact points.
Right.
You just made a really super large capacitor, a lightning bolt in a can is what I'm saying. And then fill that in with some sort of oil. Yeah, if I can get it to fill in. Anyway, fill that in with some sort of oil all the way down through there so that oil acts as kind of a, so it won't arc across this little section right in here.
All right.
All right. Charge that sucker up and see how much power you got in it. That's a 50-gallon drum size capacitor. What do you think?
That's amazing.
Yeah.
I mean, I'd be afraid to short that capacitor out.
Yeah. But the thing about it is if you've already got it connected to the load prior to charging it up at all, you don't have to worry about it. You can use a capacitor as a battery. And so if you got a massive tank like that and you bury that sucker down in the ground to where nobody can get access to it, nobody can actually accidentally get hurt by it or anything like that. You know, you don't want to learn electrical safety by accident. So you want to use precautions, obviously. But you imagine the surface area on there. And Thomas said there's a better dielectric than glass. There's something that you go by the amount of power that it takes a certain amount of voltage to literally break through. Like papers, obviously, 1,000 volts or something might burn right through the paper and leap to the other deal. But glass is a really good one. It's a really good dielectric. And so Thomas is saying that there is a better material. There's actually a chart out there, I guess, you can get for the best dielectric that it won't break down under a certain amount of voltage. So you find out what that material is. If it's easier to use than glass, then you got it made. Because you're obviously going to have somebody who can cut circles glass and then cut holes in that glass. And, basically your aluminum plate, same thing. And so you got a big hole on this side and a little hole on that side. This hole, you can thread your rod down through there. And then the next one, then, these two plates right here, the next plate up, then you rotate it around so that it, separates the positive from the negative, if that makes sense. You're talking about a bad to the bone capacitor. You could store a lightning bolt in that sucker. And then if you go to using graphene on top of that, imagine if you take and plate those aluminum plates with graphene. Imagine how much storage you could get out of that. Huh.
Shit. Lot.
That's what I'm talking about. And then if we could use a little tiny circuit like the one we tinkering around with today to charge that sucker up, and then put a big old long chicken stick out there and short that sucker out and see if it blows a crater in the earth. What do you think?
I think that sounds awesome. I mean, I would love to do that one day. Yeah, I mean that definitely is.
The only thing holding us up is resource.
Exactly. That's
You're only limited by your imagination. Anyway, we got to work our way up out here. You got any last words of wisdom before we get out of here?
Sorry, man. I'm just like really out of it right now. I'm just.
It's all right. It's all right. It was fun having the show today. So there'll be a video up for those listening in on the radio. There'll be a video up if you want to see what we was actually working on. It's like I would like to be able to just do this somehow or another, switch over from shazizz radio to shazizz TV and do both at the same time. You know what I mean? Thomas was streaming on Rumble there, so he's got a video over there as well. And if we get multiple people doing that, you know, you could actually raise you some funds if you had the capability to stream the same show that we're streaming, you know, live as we're doing this. Then there you go, man. We could get more coverage out there, and you could earn a few pennies in your bucket on your side for streaming over there, you know. And when Thomas is streaming, he makes a few pennies in his bucket to help him out. And more people we get going to doing that, we could generate the revenue necessary to do all these projects that we want. You know, pulling our combined resources and knowledge. And I love to get some of these guys that you've seen in those videos on this show, you know, talk to them about ideas that we've got, because maybe some of the ideas that we've got they hadn't thought about, and they might give it a shot, you know. I just don't like those ones that you know, are so stuck in the book. They oh, you can't do that. I shared an idea with a guy that has the talent like you wouldn't believe. This guy has all the machinery necessary to build an internal combustion engine. He could build a two-stroke engine from scrap. He could take the raw materials, put them on the lathe, put them on the milling machine, and he can build every single part of this thing. So I thought, okay, here's a guy that might be able to prove the theory about being able to run a car on an engine on water, because water is hydrogen and oxygen. If you understand on how to separate that hydrogen and oxygen on demand, it's not just electrolysis. You know, you can separate it in many ways. You know, Stan Myers was doing it with electronics. But either way, you know, if you get that down to where in the milliamp range, where you're not, like, electrolysis is the most inefficient way to separate hydrogen and oxygen. Plus, you got to put some sort of, you know, conductive liquid in between there, you know, salt in your water or whatever, you know, and so you're getting byproducts that you don't want. And I'm telling you, you don't need to do all that.
There was some pretty interesting electrolysis devices I saw back then on Patrick Kelly's channel, where they were like pulsing the electrolyzer or you know, the HHO generator, whatever you want to call it, with a coil.
Yeah.
You know, basically make magnetic field around it. And I even remember watching the video, the Sajeka files from the Energy from the Vacuum series, and Bedini had talked about, like, or mentioned, he drew up a little schematic of like a glass tube that comes in from the left, takes a 90-degree down drop, then it goes back up, and then goes out to the right. So it looks kind of like a T, and basically you put two magnets on each side, and you fill it up with water, and like it naturally separates oxygen and hydrogen.
Well, I'd like to see it, but we got to kind of try to speed up and get out of here. But last thing about that guy is he didn't mention me by name, but he made this video called Bollocks, and where literally in there he made a mockery of everything that I was trying to say. He never tried it. He never took the time to build the way that I was telling him that it needed to be built. He just made a joke out of it, and so I don't like guys like that, you know. If he would have, I would even paid him to waste his time, which he wouldn't be wasting his time because he would have got paid to do it, to build it exactly the way that I designed it. No modifications, no nothing like that. And if it failed, it failed. Either way, he got paid for the skill set that he had access to. If he would have built it exactly like, we'll never know because he never did it. But you know, everything in my mind tells me that if it was done properly, you imagine you got a tank of water, you're heating that tank of water up at 212 degrees Fahrenheit, then the water will begin to boil. You know, you start changing it into steam. And so you got a cylinder that's up to 300 degrees using induction heating. So it's got a stainless steel cylinder inside there, and it's heating that thing up to 300 degrees. So as soon as you bring this water around, it's already flashed. It's already boiling, and you're getting steam off of it. By the time you bring it in there and you break it down again through like an atomizer, and then maybe through a sonic vaporizer, which I don't have over here, I could show you what one looks like. But you turn it into a really super fine mist. Now, water, when it's turned into steam, will expand 1,600 times its volume. All right. So when you vaporize this and then you inject that down into that 300-degree cylinder, the temperature difference not far enough apart where you're going to cause thermal fracturing. So what's going to happen is when that mist hits that hot cylinder, it's going to instantaneously flash into steam and expand 1,600 times its volume, pushing that piston down. And then on the upstroke between the compression and the temperature inside there, it'll crack the hydrogen and oxygen, releasing an electrical charge inside there and igniting the two gases and slamming that piston down again. They've done water injections in diesel engines. They've done water injections in gasoline engines. They've done water injections in freaking airplanes. You know, like if your airplane gets in a stall, they had the system where they could inject a small amount of water into the cylinder and it would kick that engine over. So I know it's possible. It's not some pseudo science. It's actually, you know, they actually do stuff like that. So if he would have at least took the time to humor me long enough to try it to find out, could this possibly work? He might be famous right now. He would have built the first engine that would separate hydrogen and oxygen on demand and literally made the damn thing work. But instead, he wanted to make a joke out of it, you know. He didn't mention me by name, which, you know, I wouldn't have cared if he did. I'd have just made a second video and said, okay, well, I'll challenge you then. You say it can't be done, build to my specs, and we'll see who's wrong. And if you're right, I give you $1,000. If I'm right, you give me $1,000. What do you think?
I think that's fair.
Yeah. So that's it, man. You know, you're only limited by your imagination, and if you're not willing to go step outside the box, then you're never going to figure anything out. And I did that Free Thinkers video, you know, and I put a bunch of junk together, and I was hoping that light bulbs would start kicking on, because if you're talking about perpetual motion in a closed loop system, well, then obviously you're going to lose power somewhere, and it's not going to work. But if you want to keep something going for years at a time, I've already proven that's possible. Lid motor proved that's possible. And so literally, you know, you're gathering up energy from everything possible, whether it be radiant energy or solar or wind, static electricity, negative ion generators, earth battery technology, galvanic action, all of it, you know, and you're funneling that in to a big bank. Now imagine if you had that 50-gallon drum capacitor sitting underneath the ground, and all you was doing is dumping energy into it. See what I'm saying? And you get more electrons on one plate than you got on the other. Guess what you got? You got a charge.
Right.
So that's what I was trying to get at. Anyway, we got to get up out of here. I appreciate everybody being here, and the video will be up on Rumble. I think I might be safe to throw this one on YouTube as well. I don't think we talked about anything that YouTube can complain about. YouTube sucks, man. Anyway, it is what it is. Thanks, Brandon, and thanks, Tom.
I look forward to next weekend for sure. And we'll have some pretty awesome stuff to actually show that I'll be working on. Hopefully this week sometime. I'm going to get some stuff going.
Yeah, I'm going to try to order some different types of capacitors and see what I can do with that little Nixie tube circuit. I want to get a bunch of those because I want to do some something similar to what you did with those 2 circuits that you got from Sky Motors, Sky.
Yeah, man. If you ever want me to send you a circuit or something, let me know, man. I'll send you something. I'll build you a circuit, you know, SG circuit or whatever kind of circuit you're trying to, you know. I know you can build them if you wanted to, but I mean, I'm always for work. I would love to get paid to do this kind of stuff because this is what I love to do. I've never got paid for it, never.
Well, I'd be more than happy to pay you for different things like that. You know, this Slayer exciter circuit, I could have built that myself, but I wanted it to look good. So I got Ryan Abrams. I paid him $60 to build that coil for me in the circuit. You know, and Chris, he had the circuit put on a actual physical board. You know, so it came out. It came out pretty good. You know. See if I can keep from dumping it in the dang dirt. Oh, there it is. Anyway, he actually put it on a PCB board. And that's what needed to be done the whole time. That's my wireless energy deal right there. But Ryan Abrams, he made this coil for me. I paid him $60 to do it. I appreciated it because I wanted it to look good. I didn't want it to look like crap. I mean, I could have wound it myself. My craftsmanship leaves a little bit to be desired, but my mechanical version of how things need to work, what needs to happen, is all right. You know, so every time I tell somebody something's going to work, if I show them, you know, it's going to work. If I'm sitting there telling you try this out, it's going to work.
Well, I'd be willing to try many things you throw at me, shazizz. I really want to try that. Just let me know. You know, if I have the resources, which I do have quite a bit of stuff, you know, let me know one day. You know, we can start a project. You know,
the bottle caps for Mad Science. That was the project that I wanted to basically start funding everybody's lab with. Thomas needed some money. I wanted to give him some money. You needed some money. I wanted to give you some money. So I started this bottle caps for Mad Science project. Right, and I made some coins. Made some digital coins, which I don't want to talk about at the moment because I'm not too happy about how that worked out. It's still in existence, but I got to work out some shenanigans before I can move forward to that part of it. But got these fundraiser coins that I had put together to raise some funds to pay people to do the programming for these things right here, where literally when you go up to the dang machine and you put a bottle cap in, it makes a token just like this. And then I was going to show people what you can do with these things after that point right there. Everything from gasification to 3D printing to injection molding and much more. And so I put a hell of a lot of money behind the scenes that I didn't tell nobody about. I put a hell of a lot of money behind this deal. And some shenanigans played out. But either way, this right here is a Walmart shopping bag. All right, that material right there, that's some sturdy material. You can't break this stuff. All right.
Wow.
You could make dowel rods out of these Walmart shopping bags that you could build geodesic domes and stuff out of. You know. Now, if I could get this project up off the ground to do what I've been trying to tell everybody about, and you needed money for your dang lab, I'd hand you the money. You wouldn't have to sign no contract or even repay the damn money. I just want you to do what you said you were going to do. That's all. You said you want to try something out, even if it don't work. I don't care. Save the prototype, and we'll see. We'll troubleshoot it and see. Can it be fixed? Can we take something that's off the shelf? Can we take another piece of physics and solve the problem?
Right.
But the whole key was you give these little kids around the world, a financial incentive to want to pick up bottle caps and throw them in these machines. They can earn money that could send them through school or whatever. If they want to go to some trade school or college, or maybe just buy them something. But it gets people a financial incentive to want to recycle. And I wanted to pay people to build prototypes take everything that would have otherwise gone into the trash, build a machine, make something useful out of that. Every bit of material. I showed you the plastic bag. It makes a really super strong freaking plastic. And if you did that, you could build geodesic domes that would last for freaking decades. They weren't going to go nowhere. I mean, super strong material. But nonetheless, all these different things from construction waste to food waste to mechanical waste, whatever, everything can be recycled and everything has a monetary value. Instead of throwing it in the trash, off in the landfill or whatever, it's going to waste. Everybody in this world is literally standing on a gold mine and they don't get it. That bottle caps for mad scientists help us show the world how to turn trash into a real solution. And if I could fund your lab, if I could fund Thomas's lab and my lab and anybody else who came on the Dream Team's lab at the same time, that's what it's all about. These guys that you've seen on those videos, they got a lot of resources. They got sponsors. They got their YouTube channels monetized. Probably got their own money in the piggy bank already. They got thousands of freaking subscribers, so they probably got Patreon accounts and all that kind of crap. I don't want all that. Would it be nice? I guess you'd have some extra bucks, but I don't want to have to answer to these folks over there. I want to answer to us. I want to answer to our team and our team alone. I don't want to have to ask for permission to put a video out about something. And I want to take this trash, instead of putting it all over the planet, I want to put it into use and turn around. Tom's talking about building his replicator project. I believe he can do it. I honestly believe he can do it. And I would like to give him the money and the resources and the security necessary to do it. But until we come together, we're just doing what we're doing, man. We're scraping a few things together. We could show a lot of ideas, which is a good thing. But I watched many, many ideas go down the road. Somebody else took credit for it, and they never come back and said, hey, man, I really appreciate that idea. Here's a few pennies in your bucket so you can work on the next idea. I even told people, I'll give you ideas for free. All I want out of the dang thing is one prototype, just to prove the theory was true. It worked. Like I said, it did. I built two of these doggone neodymium magnet accelerators. There's only two of them in existence. And this one has flaws because of the way that the track was designed. It's got you can watch the video, you can hear it clack, clack, clack because there's a lip in there. I need to use some sort of vacuum forming to build a smooth track so that it doesn't do that. But the things that that thing is capable of doing, along with this thing over here and this storage back there and that circuit over in that other corner, if it was precision, if it was done properly, you'd be really impressed by what it's actually capable of doing. You know, all those stuff come up out the brain there, you know, for what it's worth. But it's unless you got somebody who's got the skills to actually, you know, put this stuff together. You get a dream team. You get somebody who can weld real good. You get somebody who can do electronics and all that. You bring them together, put all their egos aside, and everybody just start building stuff. You know, I want to give them that chance. Anyway, that's what it's all about. So I'm going to give us a peace sign up over here on Rumble, and everybody listening in on the radio, there'll be a video available after this deal, providing nothing goes wrong. So take care, everybody.